Thank you for listening to my presentation. My name is Dr. Laura Owens from RMI. This will be a summary of the MIQ performance standards experience and recommendation for utilizing an ecosystem of detection technologies to reduce methane emissions from the oil and gas supply chain. There are literally dozens of technical solutions for overseeing and capturing major and even minor events. Some are best suited for single pads, concentrated equipment like well pads or processing facilities. Some are better suited for long pipelines. Some geographic regions cannot support certain surveys, and some solutions are far too onerous, yet don't capture the biggest events over time. Some solutions are not about sensors, but detailed process models, which flag major emission events when pressure readings are triggered. This will require an ecosystem of detection solutions, one that will let us get started today. Performance standards are the key to driving down methane emissions. Operators know their equipment, they know what their staff and consultants are capable of, and they definitely know where there's room for improvement. The MIQ standard allows us to grade or differentiate all natural gas based on methane, applying a three-pronged approach, including methane intensity, detection, and best practices. For example, with the MIQ standard, to get a C grade or 0.2 methane intensity or better, an operator must deploy a top-down survey at least 2 times per year, covering the entire facility, as well as 2 times per year bottom-up, such as traditional OGI. Top-down surveys are key to identifying super-emitting events, often missed during LDAR surveys. Top-down surveys can involve drones, planes, satellites, towers, fence line monitors. A 25 kilogram per hour lower detection limit, or LDL, and a 90% probability of detection is required under the MIQ standard. Approved technologies must undergo sufficient independent challenge testing to support these LDLs, and the environmental and operating conditions under which they were tested must be met during the survey. This includes weather conditions, duty cycle, flight height. It is up to the oil and gas operator, the technology provider, and the third-party auditor to verify these conditions. All methane leaks, big and small, identified during these surveys must be included in the operator's methane totals, using GHG-ERP leaker factors or quantified emissions. For many facilities just now conducting some of their first top-down surveys, they are encountering events that effectively double or triple the reported emission totals and cannot meet their targeted C grade or intensity of 0.2%. As a result, they must now conduct more frequent surveys and, more importantly, drastically improve their handling of natural gas. Proper follow-up and repair to detected emissions is key and must be completed within 28 days. Bottom-up surveys, including Method 21, OGI cameras, are also required 2 times per year to receive a minimal C grade. This is less about the technology and more about the operators themselves. Are they properly trained? Are they surveying at the correct distance from the source? Are they targeting major emission sources? Are they recording and identifying problematic equipment for repeat surveys? Equivalency models should also be allowed, and there are several open source versions currently available. This is especially true as new tech and tech capabilities are improving over time. To illustrate, the upper plot is a simple model of monthly emissions from a real-life Permian production facility, showing similar emission reductions from 2 different top-down approaches. This flexibility will be critical as satellites with higher LDLs soon become available and can pass over entire sites much more frequently. Note, unique emission distributions must be used during equivalency calculations, as different segments of the supply chain and different geologic reservoirs produce different emission profiles. Here is a summary of what makes a strong performance standard. What a regulator should look for from various detection technologies is also summarized here. Keep in mind, detection can be sensors, engineering solutions, or new tech that hasn't been invented yet. Comparing apples to apples shouldn't be impossible. MIQ has experience and success with the application of performance standards rather than prescriptive standards, which require operators to work hard to reduce leaks to a point of meeting maximum methane thresholds. For operators, this might mean drastic increases in detection coverage or simply drastically improving company practices and attention to methane handling. By nature, these flexible requirements are future-proofed to allow for a growing commercial market of detection and quantification technologies at reducing costs. Thank you for your time.